In this section here, we're going to be talking about linear inequalities in two variables. And really what we're going to be going over is how to graph linear inequalities. And the two variables are x and y. So let's take a look at an example here. And I'm going to attempt to draw an xy axis. Let's use a color. We'll use purple. I want to graph y is equal to 1. Now you should know how to graph y is equal to 1. So we're going to let this be 1 right here. And we're just going to draw a line that passes through 1. And so there it is, right? Of course, this line goes on forever in this direction and on forever in that direction there. Okay, so that's y is equal to 1. But what if I were to say y is greater than, or let's say equal to 1? We want to graph this. So what we're saying here is we're saying, listen, all values of y that are greater than 1 or equal to 1. Well, we know equal to 1 is a line, right? And so we have an infinite number of dots here that make up this line. But greater than 1, in other words, I can pick a value up here that has a y value that's greater than 1, or one here that has a y value that's greater than 1, or up here, or over here, or over here. Right, let's not leave off quadrant 2. Okay, so any one of these values over here satisfies this inequality. Okay, and of course we can actually pick a number. We can pick a point on the line because it says equal to. But what if I were to say y is only greater than 1? Well, if I were to say y is only greater than 1, then let's redraw our graph. Okay, and redraw our line. Greater than 1 means that we can choose any number up here that's above the line, but we cannot choose a number on the line. So we indicate that by just a dotted line. A dotted line, here's 1 on the y-axis. Right, this is just a dotted line. We can't pick a point on the line, but it satisfies everything, every point above the line. Y is greater than 1. All right. Let's take a look at x. So let's say that we wanted to graph. We'll give x a different color. We want to graph x is equal to 1. X is equal to 1. Well, that would just be a vertical line that passes through 1 on the x-axis. So there's the graph. We'll put a 1 here. There's the graph of x is equal to 1. Of course, it goes in that direction or in that direction. But what if I wanted to say, no, wait a minute, x is greater than 1? Well, or let's say greater than or equal to 1. In other words, I can choose any x value to make this true that's greater than or equal to 1. For example, we can pick a point here. Has some x value. It's greater than 1. It's to the right. Okay, so you can choose any x value you want. Now don't worry about the y, because all we're talking about is this inequality here. Or what if I said x was less than 1? Right? X is less than 1. Let's look at that graph. So x is less than 1. So we want to do this. So here's 1, we'll say, on the x-axis. And, oh, that says less than, not equal to. So less than. So that means we're going to use a dotted line because we cannot use it. Well, I can choose a point here. X is 0, and 0 is less than 1. Or a point here, 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 here. Any one of these points, okay, to the left of the dotted line satisfies this inequality. And so we may just indicate that with some kind of shading. You know, we'll say, okay, we'll pretend that this is all shaded. That looks like that hit the line, but it's not supposed to hit the line. Right, so we indicate this by some kind of shading here. Right, when we look at a graph of this guy right here. Right. So we're just going to focus on how to graph inequalities. That's what this section's